Yesterday we had a look at some of the definitions of algebra. So today we're going to start using some of that algebra. So first up is substitution and equivalence. Now luckily substitution is pretty simple. You just got to think of it like soccer. You're taking one person off the field, putting someone else on. What we'll be doing is we'll be taking the pronumeral, or the question mark, the value that we don't know off the field, and we're putting a number in its place. So let's write that down. Substitution is replacing the pronumeral with a given value. So substitution is replacing the pronumeral with a given value. So for example, let's say I said A equals 6 and B equals -3. And the question might say, there's a few words they could use. It might be something like this one, evaluate. 6A minus B. Something like that. Now that word evaluate means, well, value appears in there. We're trying to find a value for 6A minus B. And that means we're going to need to substitute in the values that we know, so the 6 and the -3, instead of the pronumerals, which are like question marks, things we don't know yet. So in red below, what I'm going to do is I'm going to write 6. Remember, when there's no symbol in the middle there, it means times. So 6 times 6, because A equals 6, minus, and I'd really recommend putting brackets around any negative number that you are substituting in, because you're much less likely to make mistakes. -3. So those brackets don't actually do anything. There's nothing happening inside those brackets, but there'll be times when your calculator will stuff it up badly if those brackets aren't there, so it's a good fail-safe. Now from here, you type that into the calculator. 6 times 6, 36, minus -3, 39. Remember, minus and negative is positive, but your calculator will work that out for you. Alright, let's call that question I. Let's do part 2. Let's say we've got 3b squared minus 5a plus 7. Alright, now, this is one of those moments I was talking about where your calculator is going to get it wrong if you forget the brackets. I'll just show you over in this space here. Your calculator, if you type -3 squared, it thinks you mean do that bit first and then put a minus on the front. But that's not what we mean when we're substituting. We want to substitute the whole number -3 in here. So -3 squared, and we'll have 3 times out the front. So see, I've got those brackets around the negative number, and the squared is outside the brackets. -5 times 6 plus 7. So -3 squared, you get +9. You can see how on the calculator you'll get -9 if you try that. So that's 27 minus 30 plus 7 is 4. And there we go. So that is substituting. There isn't much more to it other than writing the number instead of the pronumeral and typing it into your calculator. The other word in the title though is equivalence. So let's talk about equivalence real quick. So equivalence is when two expressions always produce the same values. So let's have a look at something with just numbers first. So this expression, let's say 3 plus 5. Well, that gets us 8. And the other expression, so is equivalent to 5 plus 3. Those are technically different. One of them is 3 plus 5, one of them is 5 plus 3. But always they're going to be the same thing. Now, what you might see is, let's say we do a plus b is equivalent to b plus a. No matter what numbers we choose for b and a, we are always going to get the same thing. There's actually a name for it when we're talking about addition or multiplication, because you might notice as well, let's say we did x times y, that is always going to be equivalent to y times x. 3 times 5 is 15, 5 times 3 is 15. And we've actually got a name for when that happens with multiplication and addition, that it can be done in any order. We call that commutative, as in you can commute them around. Commutative law. Now that's pretty complex and something you don't need to worry about too much. It's just handy if you're trying to do some questions. Let's say you're doing, I don't know, let's say 3 times 12 times 4. 3 times 12 is 36, and then times 4, well, I don't really know my 36 times tables. But this is equivalent to 3 times 4 times 12. So 12, 3 times 4 is 12. 12 times 12 is 144. Much easier by using the commutative law. So let's just have a quick example and then you can get stuck into the work. So let's say which expression is equivalent to 3a plus 4b. Let's say we got 4a plus 3b. Sorry, just going to remember the shortcut for me out. Yeah, got it. 3. Alright, so pretty easy question, but which one's equivalent? Well, if both of those are 1, if a equals 1 and b equals 1, you get 3 times 1 plus 4 times 1 is 7. And this one, 4 times 1 plus 3 times 1 is also 7. So they are equivalent at some point, but they're not equivalent expressions because they're not always the same. If those are any other numbers, you're going to get different values for this expression and part 1. So it's not part 1. Well, part 2 is just different completely. That's negative 4a, negative 3b. We're going to end up with a very different number. Lastly, 4b plus 3a. It's out of order, but because of the commutative law, we know that addition doesn't matter which order. So we do know that these two are equivalent. Now the other way to test it is just pick some values. Let's say a equals 2, b equals 3. For the original one, 3 times 2 plus 4 times 3 equals 18. And then try it for this second one. Let's say 4 times 3 plus 3 times 2 also equals 18. So it works for that one. You probably want to try it for one more set of values and then you know it is equivalent. Alright, so look onto your emails and Canvas and have a look at what work is next.